We have got another example of solving a complex integral uh, with respect to a complex variable over a contour or a piecewise smooth curve, and the curve is defined by joining two line segments. So one is the C1 over here and the other is C2 over here. So it is shown clearly. So in our case, the function which is over here is f of z, which is x square plus iota y square. So this is like the complex function, and we have to integrate it with respect to complex variable z. So we will apply the definition, but before we apply the definition, we really need to make the parameterization of this piecewise smooth curve. But we have already seen a property that if we have a curve which is joined by two curves, c1 union, let's say c2, then what can we do? Basically, when we integrate over c uh, to this function f of z dz, uh, it can be given by c1 integral over c1 plus integral over c2. So we can make use of this property in order to solve this integral. So first I'll consider the c1, which is clearly shown, and the c1 is a line joined by the points 0 0, and I can say the other point is 1 1. Why? Because I can my 1 plus iota corresponds to 1 1 in the plane. So like this is the point. Now if I make a line out of these points, the line turns out to be y equal to x. So if it is the case, then if we set x to be t, then y also has to be t, and of course t is running between 0 and 1. Why? Because when we have x equal to 0, we have 0 0, and when we have x equal to 1, we have the point 1 1. So of course we also know that this parameterization can also be written in this form: z of t uh, to be x of t plus iota times y of t, which can again be written as t plus iota times t. Or if you take t to be common, then you have 1 plus iota. So you can write your parameterization in this way. So here the value of x is t and the value of y is also t. So now if we integrate over c1, I'll integrate over c1 over here. So what I need, basically I need a few things, quite a few things. So over c1, what I have to do basically is I have to compute this integral f of z dz. So this should be equal to a to b. So in our case, a is 0 over here and 1 is here. So this is the parameterization variable. So 0 to 1, f of z of t times z prime of t dt, right? So in our case, recall f of z is equal to x squared plus iota times y squared. But if you insert f of z of t, then it turns out to be in our z of t, x is equal to t and y is also equal to t. So it is going to be t squared plus iota times t squared, which can again be written as t squared times 1 plus iota, right? And of course you can take the derivative of the z. So the derivative of the z is equal to 1 plus iota. So if I substitute f of z of t and the derivative of z of t into the formula that we have defined for the integral over here, we will have this. We will have c1 integral of f of z over c1 to be equal to 0 to 1 times f of z, which is t squared times 1 plus I multiplied by 1 plus I dt. So 1 plus I square is a number that you can keep outside of the integral, and then you have to integrate 0 to 1 of the function t square dt. And this is not hard to integrate t cube over 3, in other words 1 over 3. So this is going to be 1 over 3 times 1 plus I squared, right? You can perform this, simple computation in the complex multiplication to get 2 over 3 times iota. So like the integral over C1 is giving me the answer 2 over 3 times iota. Now what will I do? I will be integrating my function over the curve C2. Let's now make sense of this C2, integral of z over C2. So in order to integrate this complex variable function over C2, I need to know the parameterization of C2. So let's first find out the parameterization of C2. So you can see that the C2 is a line which is, of course, a vertical line, and it is joined by 2 points. One point is 1, 1, because 1 plus iota corresponds to this point over here, and 1 plus 2 iota corresponds to the point 1, 2. Now I have to make a line out of these 2 points, and then I will, make the parameterization likewise. So if you use 2-point formula, uh, or you make sense of how you make the equation of vertical line. So equation of vertical line in this case is going to be x equal to 1. So if you don't know how to make the equation of vertical line, then you really need to go through analytical geometry where you understand how you make the equation of line when it is vertical. And of course y is running between 1 and 2, right? So y can be anything over here, but that y is anything t, but that t or anything is running between 1 and 2. So you can say that this y is running between 1 and 2, or you can also say that t is running between 1 and 2. So what will be the parameterization? So in this case, parameterization should look like z of t to be x, which is 1, plus iota times t, where t is running between 1 to 2, right? Okay, so now I have found out the so-called parameterization of my curve, and I also know my function. So what I can do, basically I can apply the formula and calculate the integral over C2. Recall f of z was equal to x squared plus iota times y squared, right? So f of z of t is going to be equal to, so z of t is over here, so x is 1 and y is t, so 1 square is 1 plus t square times iota, right? So this is f of z of t. And now if you take the derivative of this z, so the derivative of z is going to be equal to 1 has the derivative 0 and t has the derivative 1, so it is basically iota. So now what we have to do is we just have to apply the formula that says that the integral of a complex function over this curve C2 should be equal to the limits from a to b, which in our case is 1 to 2 over here, and f of z of t times z prime of t dt. So when you substitute 1 to 2, the f of z of t, which is 1 plus t squared times I, and you multiply the derivative of z, which is I, and you integrate with respect to t, you will have your answer. So so like I can take this iota outside of this integral, and then I integrate from 1 to 2 to the function 1 plus t squared times I dt. So then this is integration of a complex variable function of real variable, so that should be equal to iota times t plus t cube over 3 I, and my limits are from 1 to 2. So when you apply your limits, you substitute 2 plus 8 by 3 I minus 1 over 3 I. So you just simplify this, I remains over here, so 2 minus 1 is 1, and plus this is going to be plus 7 over 3i. When you multiply I inside, so you have I minus 7 over 3, right? If we haven't made any mistake. Hence, finally, the integral of x squared plus iota times y squared over the curve, piecewise smooth curve, is going to be equal to integral over c1 of this function. So I should have written this function. So you have to say that this is f of z dz plus over c2 f of z dz. And we have computed already this was 2 over 3 times I, and we have seen that this is I minus 7 over 3. And then when you perform these small computations, you will see that it is 5 over 3I minus 7 over 3. Or you can say that minus 7 over 3 plus 5 over 3I. So this is the integral of this complex valued function. So this is how you integrate your complex valued function, okay? Of course, over a piecewise smooth curve.